press the bell icon on the YouTube app and never miss another update.
Hello students, welcome back. The remaining topics regarding P-block elements, those are 16, 17, 18 group elements. A little bit simple discussion based on previous entrance point of view questions and important concept oriented questions. Now we have to discuss regarding 16th A group, 17th A group and 18th A group elements. This will be useful. And based on this, you can solve some more questions after completion of the content. Clear? So, the question number, so it is unit is the P-block elements. The P-block elements. So, the question number is number 1. Question number 1: which of the following is not oxidized by ozone? Which of the following is not oxidized by ozone? Simple 4 options given here. Option number 1, potassium iodide. Option number 2, ferrous sulfate. Option number 3, potassium permanganate. And option number 4, potassium manganate. So write these type of questions. How to find the answer? Which of the following is not oxidized by ozone? Oxidation means oxidation number increases. Oxidation number increases is said to be oxidation. So in this example number 1, oxidation state of iodine is -1. Iron oxidation state +2. Manganese oxidation state +7. In this example, manganese oxidation state +6. So remember, my dear students, first you have to find the oxidation state of the particular element, and after that iodine belongs to 6th group, 7th group. Iodine belongs to 7th group means it can undergoes oxidation -1 to 7. -1 to 7 means generally I- oxidized to iodine. I- oxidized to iodine. Here we are coming to this one. Ferrous salts are oxidized to ferric salts. Ferrous salts are oxidized to ferric salts because of ferrous lower oxidation number, ferric higher oxidation number. While coming to the option number 4, manganate salts. Manganate salts means Mn+6. Mn+6 manganate salts oxidized to permanganate salts. Mn+6 oxidized to +7. Fe+2 oxidized to +3. Iodine -1 oxidized to I2. I2 means 0. -1 to 0. So what about the remaining element here? Remaining compound is KMnO4. In the KMnO4, maximum oxidation state of manganese +7 only. Maximum oxidation state of manganese +7. So manganese cannot further oxidizes. Manganese cannot further oxidizes because of the +7 maximum oxidation state. Due to this, what will be the reactions between that means Ki plus O3 plus H2O gives rise to liberate I2 plus KOH plus O2. This is first equation. And FeSO4 plus O3 gives rise to you will get FeSO4 taken twice plus H2O plus H2O, and here and third one cannot further oxidizes. Why third one cannot further oxidizes? Because of the manganese oxidation state will be the +7. And fourth one KTMnO4 oxidizes to KMnO4 oxidizes to KTMnO4. So here we will get this reaction takes place in the presence of acid medium. Acid medium. And equation number 4, KTMnO4 oxidizes to KMnO4 with ozone. But equation number 3, KMnO4 no reaction. Why it was no reaction means oxidation state of manganese is +7. So don't need to write all these chemical reactions. Instead of that, simply you should find the oxidation number. Oxidation number of iodine -1 less oxidation number. Where you found oxidation number is maximum, that species not undergoes oxidation. Maximum oxidation number is equals to the group number. Manganese belongs to 7th group. So maximum 7 is for this compound further not oxidation. So right option for the question number 1 is third option, KMnO4. So here after that, second question. Next one is question number 4. Next question number 4. The number of sigma and pi bonds in peroxy disulfuric acid are. Very important question it is. Number of sigma and pi bonds we have to find. The question compound is peroxy disulfuric acid. Peroxy disulfuric acid is also called as Marshall acid. Marshall acid molecular formula H2S2O8. H2S2O8 is a molecular formula of Marshall acid. Peroxide disulfuric acid. So all sulfur acids, all oxy acids of sulfur, are dibasic. Dibasic means two OH groups will be present. So what will be the structure? This is the structure. Each sulfur contains one OH group, and the remaining sulfur atoms are satisfied with double bond oxygen. Then we have to calculate number of sigma and number of pi bonds. Number of sigma and number of pi bonds. Count the sigma bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So total sigma bonds 11 sigma bonds. 1, 2, 3, 4. 4 pi bonds. 11 sigma bonds, 4 pi bonds takes place in this example. So if you know the structure only, you will get the answer. So here answer 2 is a right option for question number 4. So make a note, answer 2, draw the structure, then you will get idea about this. And in this example, sulfur oxidation state plus 6. Sulfur oxidation state is plus 6 due to the presence of peroxy bond. And next one, question number 5. Next question is question number 5. Chlorine oxidizes sulfur dioxide in the presence of water to give an oxy acid A. Chlorine also oxidizes iodine in the presence of water to give an oxy acid B. The oxidation states of sulfur and iodine in A and B. So here chlorine 3 atom, oxide, sulfur dioxide. Chlorine plus sulfur dioxide in the presence of water. What the compound means, we get the compound is H2SO4. H2SO4 is called as the sulfuric acid. H2SO4 is called as sulfuric acid. And second example, I2 plus Cl plus H2O gives rise to, here we will get HiO3. HiO3 is called as iodic acid. One will be the sulfuric acid, second one will be the iodic acid. So here and here what we have to find, chlorine oxidizes sulfur dioxide in the presence of water to give an oxy acid A. This is A. And oxidizes iodine in the presence of water to give an oxy acid B. This is B. Then we have to calculate the oxidation states of sulfur in A and B. Sulfur and iodine. Sulfur and iodine A and B, already we know that H2SO4. H2SO4 oxidation state of sulfur. How to calculate that? 2H plus S plus 4O is equals to 0. We know that 2 into plus 1 plus S into 4 into minus 2 is equals to 0. So plus 2 plus S minus 8 is equals to 0. S is equals to plus 6. In sulfuric acid, oxidation state of sulfur is plus 6. Oxidation state of sulfur is plus 6. While coming to the iodic acid, this compound is called as iodic acid, and additional formation of HCl also takes place. That will be the byproduct, just I was not mentioned here. So only what is the main product means, main product is sulfuric acid. And second example, main product is iodic acid. So iodic acid H plus I plus 3O is equals to 0. This is a HiO3. Already we know iodine plus hydrogen plus 1 iodine as it is iodine plus 3 into minus 2 is equals to 0. So plus 1 plus I minus 6 is equals to 0. I minus 5 is equals to 0. Then I is equals to what will be the answer there? I is equals to plus 5. I is equals to plus 5 is the right answer for the question number 5. So option number 1. Option 3. Option 3 plus 6 is for sulfur, and plus 5 is for iodine. So first you have to find the answer, find the product. After finding product only you will get an answer. Otherwise we don't solve like this type of questions. So read the concept, then you will get idea about this. Clear? So option third is the right answer for this question number 5. And after that next question. After that, next one is the question number 7. Which halides is not oxidized by Mn volt? Simple question here. Which halide is not oxidized by Mn volt? Simple, you remember the answer is chlorine only. Because of chlorine is the strongest oxidizing agent. In that standard reduction potentials, standard oxidation potentials on table was there in the electrochemistry. Once you observe the electrochemistry, F2 is act as a strong oxidizing agent. So no other element cannot oxidize the fluorine. So the answer is will be the one of the conceptual question. So the answer is for this one, highest inert value of fluorine. Once you observe that table, you will get the highest inert value of fluorine. Then chlorine halide is cannot be oxidized by Mn volt. Remaining chlorine halide, bromine halide can be oxidized. Means HCl, H2R can be oxidized, but HF cannot be, because of the reason is due to highest inert value of fluorine. And next one is, so option number 1 is the right answer for this question. And the next one, question number 8. Question number 8 is a very interesting and important question. Like these type of questions you have to concentrate. And here, among the following molecule, XeO3, XeOF4, XeF6, those having same number of lone pairs on xenon. So we have to find number of lone pairs. Already while discussion about the 18th group elements hybridization concept, I was given one formula regarding hybridization. What is hybridization? Hybridization is equals to total number of valency electrons divided by, I was given, that is octet. Total number of valency electrons divided by octet. That will be the simple formula to calculate hybridizations. We want the number of lone pairs of xenon. Different compounds are there. See this XeO3 xenon belongs to 8th group. 3 oxygen atoms. Oxygen belongs to 6th group, divided by 8. Second example is XeOF4, xenon 8th group, 1 oxygen atom 6th group, number of fluorine 7 by 8, 4 into 7. Third example, xenon hexafluoride, xenon 8th group, number of fluorine 6 into 7th group fluorine divided by 8. So here first case, calculate that 8 plus 18 by 8. 8 plus 18 by 8. 8 plus 18 by 8 is equals to 26 by 8. 26 by 8 is 8, 3 is 24. These are bond pairs. So what will be the left here? Left value is 2. The left, what will be the left while doing this division? This value can be divided by helium configuration. Because moreover the elements are satisfied with the octet configuration. Less than octet, you should go through that helium electronic configuration. So divide again to 2 ones are 2. So this is lone pair. First division, bond pairs. Second division is lone pair. So in this example, total number of bond pairs, 3 bond pairs and 1 lone pair. So if you write here 3 bond pair plus 1 lone pair. 3 bond pair plus 1 lone pair in XeO3. Example 2, 8 plus 6, 14. 14 plus 4 7s are 28. 28 plus 18. So 14 plus 28 by 8, that is 20, 30, 42 by 8. 42 by 8 can be divided. 8 5s are 40. Again 2 we will get 2 1s are 2. Here 5 bond pairs, 1 lone pair. In second example, number of bond pairs 5 bond pairs. Number of lone pairs 1 lone pair. And it is 5 plus 1 6 sp3 d2. Here 3 plus 1 4 sp3. And last example XeF6. XeF6 50 by 8. 50 by 8. 7 6 is 48. 7 6 is 42 plus 8 50. 50 by 8. So 50 by 8. 8 6 is 48. Again 2 remaining. 2 ones are 2. So bond pairs, lone pair. In last case 6 bond pairs plus 1 lone pair. It is sp3d2 d3. This is a sp3d2 and it is sp3. First shape is pyramidal, second shape is actually we expect octahedral, but instead of octahedral, due to the presence of one lone pair, this is a square pyramidal, and last shape is a pentagonal bipyramidal, but here also one lone pair is there, so it is also distorted octahedral. Distorted octahedral. Then what is the question for this one? Question, once you observe the question, in this those having same number of lone pairs on xenon. Example 1 having lone pair 1. Example 2 lone pair 1. Example 3 lone pair 1. So what will be the answer? 1, 2 and 3. Fourth option is the right answer for this question. Practice like this type of questions very important for especially for JEE and Neet. They should prefer like this type of questions because this is completely based on hybridization. So you should remember this formula. Hybridization is equals to total number of valence electrons divided by 8. Divided by 8 means moreover the electron configurations are satisfied by 8. If we will get the value less than 8, then you should go to divide with 2. Then we will get first division is a bond pair, second division is a lone pair. We will get the correct answer. Clear? So option 4 is the right answer for question number 8. After that question number next question. After that, question number 13. Question number 13. Which of the following is most volatile? H2O, H2S, H2SE, H2P. So here water, hydrogen sulfide, hydrogen selenide, hydrogen telluride. These are the 16th A group hydrides. Down the group size increases, metallic character increases. Down the group size increases, metallic character increases. So the volatile, which one is more volatile, which is the least volatile, means the volatile character decreases down the group actually. Decreases down the group. But in example number 1, actually what we are expecting means the answer is H2O greater than, H2S greater than, H2SE greater than, H2T. This is the order for volatile in nature. But here we should remove this one. Why we should remove? Because of water molecule is associated with intermolecular hydrogen bonding. Remember this is intermolecular hydrogen bonding. Due to the presence of intermolecular hydrogen bonding, water is not volatile. After elimination of water, next element is what? Next compound is what? Hydrogen sulfide. So, in this question, which of the following is most volatile? Means you should go through that option number 2, hydrogen sulfide only, not water. Metallic character increases, the behavior of volatile nature decreases. So according to metallic character means oxygen, sulfur, selenium, tellurium, down the group metallic character increases. We expect more volatile for water, but water is less volatile compared to all elements. Why water is less volatile? Means due to the formation of intermolecular hydrogen bondings. So remove of this water, the remaining compounds 3 will be there. On that 3 you should find out which one is more volatile. Means hydrogen sulfide is more volatile. This point very important. Keep in your mind, this was very important for the exam point. Clear it is. So after this, so option number 2 is the right answer for this question number 13. And next after question number 13, Question number 15. After question number 13, question number 15. The element evolving two different gases on reaction with concentrated H2SO4. One and only element. Simply you should find that. Question number 15. C plus concentrated H2SO4. Property of concentrated H2SO4. Once you go through that, we will get idea about this. Chemical properties of concentrated H2SO4. In example, we will get CO2. SO2, H2O. This will be the reaction. Carbon reacts with concentrated H2SO4, liberate one is carbon dioxide gas, second one is sulfur dioxide gas, and liberate water. Clear it is. If phosphorus is there, we will get phosphoric acid. Sulfur is there, we will get sulfur dioxide. Clear it is. So, if you remember, one and only the element carbon, which combines with concentrated sulfuric acid, gives rise to carbon dioxide, sulfur dioxide, and liberator and formation of what is water molecule. So this is the question number 15. So option number 2 is right answer for this. Option number 2 is right option. After that question number 16. After that question number 16, on addition of concentrated sulfuric acid to chloride salt, colorless fumes are evolved. But in case of iodide salts, violet fumes comes out. This is because. So here MCl plus H2SO4 will get what? Colorless. MCl plus H2SO4 is colorless. Second one is Mi plus H2SO4 is equal to what is the violet fumes. Violet fumes. Then what reaction takes place? Why it was colorless? Why one more is violet color instead of MCl? Consider even KCl. So what will be the reaction? It is MCl plus H2SO4 gives rise to MHSO4 plus HCl. MHSO4 plus HCl. In second case, consider Mi metal iodide plus H2SO4 gives rise to. Here also MHSO4 plus HI. MHSO4 plus HI. So here the concentration of sulfuric acid is more than the concentration of HCl. Concentration of sulfuric acid is HCl strength is more than H2SO4. HI strength is more than H2SO4. This will be the order. What is the order means? Strength of HI greater than strength of H2SO4 greater than strength of HCl. Strength of HCl. So you should go through this order. Strength of hydroiodic acid is strong compared to sulfuric acid compared to hydrochloric acid. Due to that reason, in second case we will get violet fumes. In first case we will get colorless. First case we will get colorless. So what will be the correct answer for this means HI gets oxidized to iodine. HI gets oxidized to iodine because iodine in this example -1 state and in this example iodine vapors HI plus H2SO4 is in this case we will get what it is I2. I2 means here 0. Oxidation state of iodine is 0. Due to that reason, what will be the answer for this question number 16? Question number is 16. Question number 16. So what will be the answer means HI get oxidized to iodine because in this case we will get HI only. This HI later we will get oxidized. So that will be the right answer for the question number 16. You should remember this very important. HI get oxidized to iodine due to the strength of HI is more than sulfuric acid, more than hydrochloric acid. So right answer for question number 16. Third option is the right answer. HI gets oxidized to iodine. And next one, question number. Next question is 25. Br minus is converted into Br2 by using. Br minus is converted Br2 by using. Simple here. chlorine, chlorine, bromine, iodine. Ability of oxidation character. Chlorine can displace chlorine, bromine, iodine. Chlorine can displace bromine, iodine. Bromine can displace iodine only. Iodine cannot displace chlorine, chlorine, bromine. Bromine cannot displace chlorine, chlorine. Chlorine cannot displace chlorine. So here Br minus is converted into Br2 by using only one and only answer is that is Cl2. Cl2 plus Br minus gives rise to Cl minus plus Br2. 2Br minus 2Cl minus. Simple equation this is Cl2 plus 2Br minus gives rise to 2Cl minus plus Br2. The ability of oxidation character. Chlorine is powerful strong oxidizing agent. After that chlorine next chlorine next to bromine after iodine. So remember my dear students, chlorine can do anything, but chlorine cannot do. Chlorine can displace bromine and iodine, cannot chlorine. Bromine can displace iodine only. Iodine cannot displace anyone. Already in synopsis classes already we discussed this property. Go through that, then you will get idea about it. So what will be the right answer for this question number 25? The right option is Cl2. Cl2 is the right answer for the question number 25. After that question number 25, next number is 29. After 25, next 29. 29 conceptual question. This is mark the halogen that gives only one oxo acid. That is answer is fluorine. Option 20. Question number 29. Option is fluorine. Why fluorine? Means electronegativity is more, electron and size less, small in size, more electronegativity. That only the reason. Answer is a fluorine. One and only fluorine. Fluorine only form only one oxy acid. Remaining elements are formed different type of oxy acids. Chlorine form 3 oxy acids, 4 oxy acids, bromine form 3 oxy acids, iodine form 3 oxy acids, hypochlorous, chlorous, chloric, perchloric, like that oxy acids already we discussed in theory class. So one and only fluorine is formed only one oxy acid. That oxy acid is called HOF, hydrofluorous acid. HOF, that is called hydrofluorous acid. And next question number 32. Question number 32. Next, the character of solubility in water for helium, neon, argon, krypton, xenon is. This is very very important and interesting question because in examination point of view we expect this question. So down the group solubility increases. Down the group solubility increases. Very very important. Boiling points increases, solubility increases for noble gases. So down the group solubility increases means helium, neon, argon, krypton, xenon. Eliminate the radon, which is more soluble, means xenon is more soluble. After xenon, krypton. After krypton, argon. Argon after neon. Neon is last is helium. So question number 32. Write the reason. Down the group solubility increases. So xenon, krypton, argon, neon, helium. This is the right answer for that question number 32. Option number 3 is right answer. After that, next question number 30. Next one is question number 35, 37. So next question 37. Oxidation. This is very important question. Oxidation state, covalency of sulfur, and the total number of lone pair of electrons in SA molecule are respectively. Very important question is oxidation state we have to find, covalency is find, and the number of lone pairs in SA. 37 question. SA, just like as a crown shaped ring it is. This is like this. This will be the geometry of SA octaatomic. Sulfur is an example for octaatomic. And once you observe sulfur is in elementary state, already you know that the sum of the oxidation states is equals to 0 in a compound. For elements does not exhibit any oxidation state, so that is 0. So what is number 1? Oxidation state. Oxidation state is 0. Oxidation state 0. And second one, covalency. Covalency means sulfur surrounded by how many bonds? Each sulfur atom surrounded by how many bonds? Sulfur atom surrounded by 1, 2. Any sulfur you consider. You consider any sulfur, it was satisfied with only 2 bonds. So covalency 2. And lone pair of electrons. Actually, this is not octet. Once you found this crown shaped, and in this crown shaped single sulfur atom also not in octet. For octet still it required 2 pairs. Each sulfur required how many pairs? 2 pairs. 1, 2, 3, 4. Then it is octet. 2 plus 2, 4 electrons. 4 plus 4, 8 electrons. So each sulfur consists 2 lone pairs. So this will be the correct structure of the compound. Just a crown shaped structure it is. And count number of lone pairs: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So number of lone pairs. Number of lone pairs are 16. So what will be the answer is 0, 2 and 16. 0, 2 and 16 is the second option. Second option is the right answer for the question number 37. So draw the structure and find the answer like this type only. Clear? After this, next one. Question number 38. Paramagnetic oxide of chlorine is. 38. Paramagnetic oxide of chlorine. Simple here. ClO2, Cl2O6, Cl2. Already we know that paramagnetic, what will be the reason for paramagnetic? Paramagnetism is due to presence of unpaired or odd number of electrons. This was the reason. Due to the presence of unpaired electrons or due to the presence of odd number of electrons. If you found odd number of electrons, the number of electrons is equal to group number. If group 15 means 15 electrons odd. Group 16, 16 electrons is even. Even though but oxygen is paramagnetic according to the molecular orbital theory. According to the molecular orbital theory, we said that oxygen is paramagnetic. So here once you observe the examples, it is 17 atomic number of chlorine, oxygen atomic number 8 into the 16, don't consider given number it is. Here 17 into 34, 34 even number. Here 17 into 2, here also 34, 8 even number, 8 even number. So here first example once you observe, first example is an paramagnetic substance. Why example number 1 is paramagnetic substance? Due to the presence of odd number of electrons. This is not available in the form of dimeric. It is not available in the form of dimeric chlorine dioxide. It is not available in the form of dimer, and it contains 17 electrons only. 17 electrons means 8 pairs plus 1. 8 pairs plus 1, 1 is the odd number of electron. Due to the presence of odd number of electron, ClO2 is an example for paramagnetic substance. So right answer for the question number 38 is first option is right answer. So make a note, first option is right answer for the question number 38. And next question number after 38, next is 39. Which is the strongest of the following acids? Which is the strongest of the following acids? This is very, very important question. The strongest acid, you should remember, this is XeO4. XeO4 is called as perchloric acid. Perchloric acid is the strongest acid. Perchloric acid is only the strongest acid, After that, sulfuric acid given, hydrochloric acid was given, nitric acid was given. Compare these all oxy acids, chlorine oxy acid, sulfur oxy acid, nitrogen oxy acid, except HCl. Except HCl, because of HCl is not oxy acid, HCl is the halide of chlorine, halide of 70th group element. So out of that 4 examples, perchloric acid, HClO4 is the strongest oxy acid, and it cannot further oxidizes. Further cannot be oxidized because of the maximum oxidation state of chlorine is a +7 oxidation state. +7 oxidation state because of 4 oxygen atoms, -4 into -2 into 4 -8. One hydrogen +1, so oxidation state of chlorine is a +7 oxidation state. So perchloric acid is the strongest oxy acid compared to remaining all examples. So we can note that is option number 1 is the right answer for the question. And next, actually, what will be the order means you should follow the order is HClO4 greater than HCl greater than H2SO4 greater than HNO. This will be the order. This will be the order for the question, previous question. HClO4, HCl, H2SO4, HNO3. 5th group, 6th group, 7th group. From left to right, non-metallic nature. Top to bottom, metallic nature increases. Metallic nature increases means bases. Non-metallic nature increases means acids. First you should give the pRi for chlorines, later sulfur, next is the nitrogen. So this will be the order for the question number 39. And next question number 40. Question number 40 is related to hybridization. Question number 40. ClO3 minus the hybridization states of the chlorine atom in the ions. The hybridization states of the chlorine atom in the ion. Already I was given one formula recently. Hybridization is equals to what is the total number of valency electrons divided by octet. This formula you can use if you want to find number of lone pairs, number of bond pairs. This formula will give perfect number of lone pairs, number of bond pairs by using this formula. What is here in this example? Oxides. So an exception. This is not exception, and you should make a note for oxides. For oxides, hybridization is equals to, for oxides, hybridization is equals to central atom group number divided by 8 for oxides. Whatever the oxides was there, simply you should don't consider that oxygen, only you consider the single element. You consider the single element. So here, what are the options was given? ClO4 minus, ClO3 minus, and last ClO2 minus. Remove oxygens. What is central atom in this example? Central atom chlorine. Chlorine belongs to which group? 7th group. Chlorine belongs to 7th group plus what is the charge here? Minus. Minus charge you should add to 1. 7 plus 1 by not 8 sorry, by 2. 7 plus 1 by 2 is equals to 8 by 2 is equals to 4. What is 4? sp3 hybridization. sp3 hybridization takes place in ClO4 minus. Next example also same 7 plus 1 by 2. Next example also same 7 plus 1 by 2. Simple formula it is. According to this formula you have to save the time. This will be the simple easy formula. This formula is applied for only for oxides. If any oxide is there, you should go like through this method only. Remove the oxygens. What is remaining? Only one element you consider chlorine. Chlorine belongs to 7th group. 7th group, and one charge is there minus 1. Minus 1 you should add plus 1. 7 plus 1 8 by 2. 8 by 2 is equals to 4. 4 times sp3. In this example also sp3. This example also sp3. Suppose there was given SO2 was given. Suppose remove oxygen, sulfur belongs to 6 group. 6 by 2 is equals to 3. What is 3? You will get sp2. 3 is sp2. 3 is sp2 means one S orbital remaining 2 are the p orbitals. Here we will get 4 number. What is 4 number means? 4 is one is S orbital remaining 3 are the p orbitals. Like that you have to split the 4. You have to split that 4 number, then you will get idea about that. If 5 number you will get sp3d. 6 number you will get sp3d2. 7 number is sp3d3. Like that you have to implement that skills, then you have to find the options like this type of questions. So in this question number 40, all compounds are exhibit same hybridization, that is sp3 hybridization, the correct option is option number 1 is wrong answer, option number 2 is wrong, option number 3 is right. sp3 in all the species, sp3 in all the species. So that is the right option for the question number 40. And next question number 41 also hybridization related only. Simple question it is. Easy to find the answer. Like this type of questions are easy to score. Within 30 seconds you have to find that answer. Total number of lone pair of electrons on xenon atom in XeOF4. Already we done in this one. 41 question. XeOF4. Simple here. Xe 8th group, oxygen 6th group, number of fluorines 4, fluorine 7th group, total value divided by 8. Then 8 plus 6 14, 28 by 28 plus 8 14, 42 by 8 5s are 40, bond base, and remaining 2, again this 2 divided by 1, lone pair. So total number of pairs 5 bond pairs plus 1 lone pair, total 6 pairs, sp3d2. sp3d2. Hybridization is sp3d2. Shape of the molecule is octahedral. Shape of the molecule octahedral, but due to the presence of 1 lone pair, this is a square pyramidal. And what about the question for the this one? The question 41 is the total number of lone pair of electrons on xenon atom in XeOF4. How many lone pairs? 5 bond pairs, 1 lone pair. So option 2 is right answer. Option 2 is right answer for question number 41. And next question number 42. SF6 is exceptionally stable. Very important. SF6 is exceptionally stable due to only hexafluorides only stable. Hexafluorides only stable due to the SF6. Why SF6 exceptionally stable means this is a theory oriented conceptual question. Steric reasons. Due to the steric reasons, SF6 is exceptionally stable. This particular point also there in your NCERT text. Once you should read already, you finish this topic. I think it is because already it was over. So you will get idea about this. So SF6 why was more stable due to the steric reasons. Steric reasons is the right answer for the question number 42. And the next question is after 42. Next question: the volume of noble gas mixture obtained from 1400 ml of dry air. 1400 ml of dry air. Already we know that dry air contains 1%. 1% of noble gases present in the dry air. So here 1400 ml. 1400 ml means 45%. 1000 ml contains 1%. Suppose 1000 ml contains 1%. Then you have to calculate how much 1400 ml contains how much percentage. 1400 into 1 by 1000. 0.0000. Sorry, 100 ml contains. 100 ml contains 1%. 100 ml contain 1%. Then what will be the 1400 ml of dry air contains how much means that is what will get 0 get cancelled. To get the answer is 14 ml. We will get the answer is 14 ml noble gas mixture is present in 1400 ml of dry air. So you should write that answer 100 ml dry air contains 1% noble gas. 100 ml dry air contains 1%. This is a physical property was given in the text. Based on that, you have to solve this question. Here, suppose there was given 1200 ml means so answer is 12 ml. 1400 ml was given, so answer is 14 ml. But for competitive point of view, we never expect numericals from P block elements. Suppose if this type of questions we expect for JEE, engineering side we expect, but medical stream it was not expected. So if you arise like this type, if you found like this type of questions, you have to solve like this method, because 100 ml air contains 1% of noble gas. 1400 ml air contains 14 ml noble gas. So this is the question number 45. After that 45, next 47. Question number 47. Very very important. Question number 47. T-shaped molecules are T-shaped molecules. T-shaped molecules. Where we found T-shape? T-shape is first we have to find hybridization. Which hybridations? sp3d hybridization. Here if you write sp3 hybridization, trigonal, bipyramidal, 5 bond pairs plus 0 lone pairs. 5 bond pairs plus 0 lone pairs, trigonal, bipyramidal. Then seesaw shape, 4 bond pairs plus 1 lone pair. T shape, 3 bond pairs plus 2 lone pairs. And linear is the 2 bond pairs plus 3 lone pairs. This will be the additional information regarding sp3d hybridizations. sp3d hybridization. The value will be 5. If the value will be 5, that is sp3d. sp3d generally undergoes trigonal bipyramidal exmeter. If you found 4 bond pairs, 1 lone pair, seesaw. 3 bond pairs, 2 lone pairs, T shape. 2 bond pairs, 3 lone pairs, linear. So 3 examples are given. One is CnF3, second one ICl3, third one is BrF3, and last one is all of these. So option 1, CnF3, Cl 7th group, number of chlorine is 3, again chlorine also 7th group, so total 28 by 8, 28 by 8. Next ICl3, iron is 17th group, and number of chlorine is 3, chlorine belongs to 7th group, here also 28 by 8, and next BrF3, bromine 7th group, number of chlorine is 7, and here also same 28 by 8. Divide 28 by 8, 8 3 is 24 bond pairs, remaining 4 will be there, 2 to the 4 lone pairs. How many lone pairs? 2 lone pairs. Number of bond pairs? 3 bond pairs. 3 bond pairs, 2 lone pairs, total 5. 3 bond pairs, 2 lone pairs, total 5. This shape of the molecule is T shape. So all the examples, chlorine trifluoride, iron trichloride, bromine trifluoride, all examples belongs to same shaped molecules, that is T-shaped molecule, because all are having same number of lone pairs and same number of bond pairs. 3 bond pairs, 2 lone pairs, because same number will get 28 by 8. 28 by 8 on division will get 3 bond pairs, 2 lone pairs. So answer option 4 option is the right answer for the question. All of these. So all of these is the right answer for this question. And the next one is next, this is the last question for this session, and one more session. Till then, we have to discuss some more questions regarding this P block that day. Starting already, we finished 15 group elements. On that sheet only, these remaining questions will be there. So here, last question, that is 50th question. Which of the following reaction O2 is not formed as one of the product? Very very important. This is. Which of the following reaction O2 is not formed on one of the reaction? First example, KClO3. KClO3 potassium chloride are decomposed, gives rise to KCl plus O2. KCl plus O2. While coming to the second example, PbS plus 4O3. This is oxidation reaction. PbS is converted into PbSO4 and liberate O2. And third example is not liberate O2. While fourth example, peroxides. Peroxides treated with MnSO4. MnO4 and H2SO4. It is also, in that example also we will get O2. So what will be the right answer for the question number 50 means right answer is third option is the right answer. So once you should go through that equations. According to the equations we have to find the right answer for that. So you should note down that equation for the third one is K2Cr2O7 plus SO2 plus H2SO4 gives rise to Cr2SO4 taken place, chromic sulfate it is, and formation of K2SO4 and formation of H2. Here this will be the third reaction. Remaining all reactions liberate oxygen. In fourth reaction also NaDSO4, KDSO4, MnSO4 and liberate O2 also takes place in last example also. Except the third one potassium dichromate. Potassium dichromate treated with sulfuric acid plus SO2. Sulfuric acid plus SO2 will get chromic sulfate. This is Cr2SO4 taken thrice. Cr2SO4 taken thrice plus KTSO4 plus H2O we will get. So this is in this example there is no expectations of oxygen, dioxygen. So remaining all will be liberated dioxins except the option number 3. So option number 3 does not liberate dioxin. So I hope you understood, my dear students. So practice the equations, read the concept, then you will get idea about this. Have a nice day. Stay with us. Thank you.